Hello friends, and welcome to this tutorial on plotting experimental data. At the end of this tutorial, you will be able to define a list of numbers, perform element-wise squaring of the list, plot data points, and plot error bars. One needs to be familiar with the concepts of plotting mathematical functions in Python. We will use data from a simple pendulum experiment to illustrate. As we know, for a simple pendulum, length L is directly proportional to the square of time t. We shall be plotting L and t square values. First, we will have to initiate L and t values. We initiate them as sequence of values. We define a sequence by comma separated values inside two square brackets. This is also called a list. Let's create two sequences L and t. That is, L is equal to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 and 0.9, and t is equal to 0.69, 0.90, 1.19, 1.30, 1.47, 1.58, 1.77, 1.83 and 1.94. To obtain the square of sequence t, we will use the function square with argument t. This is saved into the variable t square. So type t square is equal to square within brackets t. So t square and hit enter. Okay. Now to plot L versus t square, we will simply type plot within brackets L comma t square comma within single quotes dot. Here single quotes dot displays the plot in a dot pattern. You can also specify 0 for big dots. For this, let us clear the first plot. Type CLF closing brackets and hit enter. Then type plot within brackets L comma t square comma within single quotes O. Hit enter. Okay. Now to clear the plot, type CLF closing brackets. Let us move further. For any experimental, there is always an error in measurements due to instrumental and human constraints. Now we shall try and take these errors into account in our plots. So pause the video here and try out the following exercise and resume the video. Plot the given experimental data with large dots. The data is on your screen. It's given in delta L and delta t. We shall again initialize the sequence values in the same manner as we did for L and t. Now to plot L versus t square with an error bar, we use the function error bar closing brackets. Before plotting the data, we need to get the data of delta L and delta t. So delta L is equal to within brackets 0.08, 0.09, then 0.07, 0.05, 0.06, 0.00, 0.06, 0.06, then 0.01, and delta t is equal to 0.04, 0.08, 0.03, 0.05, 0.03, 0.03, 0.04, 0.07, 0.08. Now use the error function. Type error bar within brackets L comma t square comma x ERR is equal to delta underscore L, comma YERR is equal to delta underscore T, comma FMT is equal to, in single quotes, BO. This gives a plot with error bar of X and Y axis. The dots are of blue color. The parameters XERR and YERR are error on X and Y axis. And FMT is the format of the plot. Similarly, we can draw the same error bar with small red dots. Just change the parameters of FMT to R dot. So for that, type CLF closing brackets to clear the plot, and then type error bar within brackets L comma T square comma XERR is equal to delta underscore L, then comma YERR is equal to delta underscore T, comma FMT is equal to, in single quotes, R dot. Then hit enter. You can explore other options to error bar using the documentation of error bar question mark on terminal. Pause the video here and try out the following exercise and resume the video. Plot the given experimental data with small dots and also include the error in your plot. The data is on your screen for delta S and delta N. So this brings us to the end of this tutorial. In this tutorial, we have learned to declare a sequence of numbers using the function array, to perform element-wise squaring using the square function, to use the various options available for plotting like dots, lines, and also to plot experimental data such that we can also represent error by using error bar function. Here are some self-assessment questions for you to solve. First one, square the following sequence. Distance underscore values is equal to, within square brackets, 2.1, comma 4.6, comma 8.72, comma 9.03. And the second one, plotting L versus T in red pluses. And the answers. To square a sequence of values, we use the function square. So that you have to type square within brackets distance underscore values. And for the second question, the answer is we pass on additional arguments stating the desired parameter. So type plot within brackets L comma T comma within single quotes R plus. So we hope you have enjoyed this tutorial and found it useful. Thank you.